Okay, hi guys. So this is the second video for elliptic curve cryptography. The one which is the other video, there we are going to plot, or there we have plotted few points on the elliptic curve, but here we are going to talk about elliptic curve cryptography for p plus q and 2p, which is another criteria for this curve cryptography. So basically there are certain points that we need to discuss. Now before that, we'll just go through the basics once again. Okay, so what is elliptic key cryptography? I mean, what is elliptic curve cryptography? Sorry. So elliptic curve cryptography, this is an asymmetric key cryptography, like it's specified over here in the PPT, and it is often compared with RSA. Now you can find the difference in the book called Stallings. What is the difference between RSA and the elliptic curve cryptography? So basically the difference is it provides equal security with smaller key size and high security. So it provides security but with smaller key size. So RSA requires a much more larger key size than this elliptic curve cryptography, which is ECC. Okay, so moving on, we are going to discuss this. So general equation for this elliptic curve cryptography is y square is equals to x cube plus ax plus b. We have already discussed this in the previous video. So basically what happens is, if you draw a point starting from here, it is actually going to intersect 3 points. Okay, 3 points in the curve. Okay, one is this, one is this, and one is this. What is a and b? A and b are nothing but these are constants. Okay, now we'll just see what are the properties. So these are the properties. It is symmetric to x axis, and if you draw a line, it will touch a maximum of 3 points. We have already seen that over here. If you draw a line, it will touch 3 points. These are some of the properties. Then, which is a very important question for your exam, that is a trapdoor function. It might come for 2 marks. What is a trapdoor function? Now you need to explain this with this diagram, now, and also an example. Okay, so what is a trapdoor function? A trapdoor function is a function that is easy to compute in one direction, yet difficult to compute in the opposite direction. So when you are solving a particular function, it is easy to go from this side to this side in one direction, but when you want to go back, I mean you want to do the inverse, it isn't possible. Okay, it isn't possible, or it is very difficult to do that. Okay, so this is trapdoor function. There are certain algorithms you can search in internet, that which algorithms follows trapdoor function. You can find that over there. Now moving on, this is okay. Let me just explain this diagram as well. So you can see that when you are going from x to fx, I mean the function, it is very easy, it's written here easy, but when you are trying to go back, it's harder. Okay, it's very hard. So but it's easy if given t. Okay, so t is the trapdoor function. Okay, so this is a trapdoor function. Then we have the algorithm for ECC, or elliptic curve cryptography. It's very elaborately written in this particular PPT. I'll just share this PPT, but let me just go through this with you guys. So let EPAB be the elliptic curve. Okay, this is the elliptic curve. Consider the equation q is equals to kp, sorry, where qp are the points on curve and k is less than n. If k and p are given, it should be easy to find q, and if you know q and p, it is difficult to find k. It's the simple that we have seen just in the previous slide. It is the trapdoor function. Okay, so one side it's easier, but to return the inverse is difficult. So next is the key exchange. As far as we have seen in all the algorithms, you have one algorithm, you have key exchange, you have key generation. Okay, so and you have decryption as well, encryption as well. Okay, so what is key exchange? You have global public elements. There is a particular element which is g, which is a point on curve or elliptic curve where order is large value of n. Then you have user a key generation. Okay, user a ka site ka key generation. So select private key na. Then you have eq is equals to, just a second, eq is equals to elliptic curve with parameters a, b and q. Na is less than n. Pa is equals to na into G. Okay, select private key NB is less than N, PB is equals to NB into G. Okay, so all these are private key and public keys. Moving on, you have the secret key by user A, so it's again a particular expression. Then you have a secret key by user B, another expression. Just the suffix A and B have been exchanged, nothing else. Then you have the encryption. Let the message be M, encode M into point on elliptic curve. Let this point be PM. For encryption, choose a random positive integer. The cipher point will be CM is equals to KGPM plus KPB. Okay. Then you have ECC decryption. For decryption, multiply first point. Basically, we are getting back what we have set for the encryption. Okay, this is the whole fundamental thing. So PM is basically, we'll just go back over here. So PM is basically what we had got the original point. Okay, so that is your final thing. Okay, so this is the decryption. Then we have, okay, so this is already, this particular point is already discussed in the previous video. You can see that point. Now we are going to basically discuss this. Okay, so 2p, okay, 2p and p plus q, we are going to discuss these two things. Let's just discuss that with one particular example. Let me just a second. Okay, okay, so let us just consider the elliptic curve y square is equals to x cube minus x. Okay, this is the elliptic curve. Okay, and say I have okay, let us consider, just write these things. Let us consider p and q. Okay, let us consider p and q. Okay, so this is a particular, say we have one particular diagram, or say we can say the curves. So we have 2 points. Let us consider the point P and Q. So say this is the P point and say this is the Q point. Um, Q point. Okay, and the coordinates are respectively x1 and y1, and you have x2 and y2. Okay, so uh, if we join these points, okay, we join and we extend it, it will make another point by intersecting. Okay, this is the another point. So we have 3 points, one this and this. So it will make another point by intersecting. And if we find another point by taking its mirror image, say like this is the another point. Okay, so this is p plus q point, which is x3 comma y3. This is x3 comma y3. Okay, I'll just explain this once again. So we have just taken 2 points. One is p, another is q. X1 and y1 is p and q is x2 comma y2, and we have taken another point which is intersected in the curve, and we have taken the mirror image of that point, which is p plus q, which is x3 comma y3. Okay, so we have found another point by taking its mirror image about the horizontal axis. Okay, and this point is referred to as p plus q. Now how do we find p plus q? How do we find p plus q, or the coordinates p and q? That is the main question. Okay, so to find the coordinates of p and q, we have an expression. Let us just assume, আমরা ধরে নিচ্ছি that p be x1 and y1. Okay, and q be x2 and y2. okay, and that of p plus q, and that of p plus q is equals to x3 comma y3. Let us just consider all these points. Okay, so we need to find what we need to find x3 and y3. Okay, which is p plus q. Now to find that, what we need to do is, let's just solve it out. We need another ppt. Wait just a second. Okay, so for p plus q, okay, which is x3 is equals to y2 minus y1. All are these expressions, you need to write it down. X2 minus x1 whole square minus x1 minus x2. Okay, so to find the point y3, again the same thing. Okay, so to find the point y3, it is minus of y1 plus y2 minus y1 by x2 minus x1 into x1 minus x3. So this is the whole equation. Just write it down. Then what we have to do is, let's just go back. So x3 and y3 can be calculated by the previous expressions. By these expressions we can calculate the x3 and y3. So to find out the point p, 2p, okay, to find the point 2p, p is equals to q. Okay, so x3 is equals to 3x1 square plus a plus by 2y1 minus 2x1. Okay, and y3 is equals to minus y1 plus 3x1 square plus a by 2y1 x1 minus x3. Okay, now here the question arises, what is a? Okay, what is a? So a is nothing but a is, when I told you guys that the equation, general expression for elliptic curve is y square is equals to x cube plus ax plus b. So this a is that a. Okay, this is the whole fundamental thing. Now let's just solve one problem out here. Okay, so say the example in the question, they asks you that on the elliptic curve y square is equals to x cube minus 36x. Okay, and p is equals to minus 3 9, and q is equals to minus 2 8. Okay, so they tell you to find p plus q and 2p. Say this is the whole question. So for p plus q, what you need to find is, I have already told you, x1 is equals to minus 3, and x2 is equals to what, minus 2, and y1 is equals to 9, and y2 is equals to 8, respectively, from the question. So x3, how you will find x3? It is just and just putting the values into those formulas, nothing else. Please make sure that the plus sign, minus sign you are putting in place and correctly. Okay, so x cube is equals to, just as we had seen in the previous slide, x3 is what? x3 is y2 minus y1, right? So it is 8 minus 9 by minus 2 plus 3 whole square minus, yeah, I think I'm doing right, minus 3 minus 2. Okay, so this is 1 square plus 3 plus 2, which is equals to 6. This is x cube. Now moving on, what we need to find out is y3. Okay, y3 is minus 9 plus 8 minus 9 minus 2 plus 3. Then you have, here it was x1 minus x3, right? So minus 3 minus 6. Fine. So what you get is minus 9 minus 1 minus 9 is equals to 0. So ultimately you get 0. Okay, so this is y3 which is equals to 0. So p plus q is equals to 6 comma 0. This is p plus q. So for 2p what you need to do is, for 2p, so we only consider, for 2p we only consider x1 is equals to minus 3 and y1 is equals to 9. We consider only this. Let's just put it in place and then find out. Okay, so the expression what we had found out is x1 is equals to minus 3 and y1 is equals to 9, right? So the expression a is minus 36, right? Minus 36. Now what you need to do is x3 is equals to um, 3 minus 3 whole square plus minus 36, okay, by 2 into 9. Okay, 2 into 9, and this is whole square minus 2 minus 3. So what you get, the value is 27 minus 36 by 18, this is whole square, plus 6, right? So this you get as 1 by 4 plus 6 now, which is equals to 25 by 4. Okay, this is the x3 part. Then we have y3 is equals to minus 9 plus 3 into 9 minus 36 by 18. Okay, and you have minus 3 minus 25 by 4. Okay, so this you get the value as minus 35. Please check whether the answers are correct or not. You will be able to do that. So for 2p ka value you get what? You get one value as I think it was 25 by 4, 25 by 4, and the another value is minus 35 by 8. So this is your entire equation. So I'll just go walk you through this again. So this is basically the example where you need to find p plus q and 2p separately. So from the equation what you have found out is x1 and x1 x2 y1 y2 from the question itself. Then we have just put the values in the equations that we had got in the previous slides. We have just put the values. So we got x3 ka value as 6, then we got the value for y3 ka value which is 0, and then the whole thing that stands out is 6 comma 0. So for 2p we only consider x1 and y1. Okay, now which is, I mean, the rest parts we have just cancelled it out. x1 is minus 3 and y1 is 9. So we have just put it all in place, and a is minus 36. So from the equation itself only, so we got 25 by 4 and minus 35 by 8, which is in return 2p is equals to 25 by 4 minus 35 by 8. Okay, so this is how we got the whole thing. Now there is another thing which is modulus. Okay, let's just do that again.